Welcome to the Interop, the show which talks about the technologies that are powering the interchain. My name is Sébastien Couture, and today I'm here with Sergey Gorbunov, who is CEO of AXLR. Hey, Sergey.
Hey, great to be here.
Thanks for joining me in our sort of quest to understand cross-chain technologies and blockchain bridging. We are doing quite a few interviews with projects that are in this space, and we can't have a proper bridge series without talking with AXLR, because they are certainly one of the biggest and certainly one of the most recognizable actors in the space. So we've got a full list of things to discuss here today. We're going to be getting deep into the weeds of AXLR and how it works. But first, if you enjoy this channel, please consider subscribing and hitting the bell so that you get notifications whenever we do live streams, typically on Thursday. And also consider staking Evmos to our Evmos validator. You'll find the link for that in the show notes. I also want to let you know that I'm going to be attending Cosmoverse next week in Medellin, and I'm super excited about it. I'm sure lots of people in the Cosmos space who listen to this podcast are also going. I think you'll probably have some people from your team there as well. And the Nebular Summit Conference and Anoma are teaming up to put on a side event on September 27th at 5 p.m. It is called Interchain Travel, and we're going to be exploring all sorts of interesting topics around interchain, Web3, privacy, security, and consensus. We have a pretty stellar lineup of speakers lined up for this event. So Ethan Buckman of Cosmos and Informal Systems will be speaking. Susanna Adevans, who's project lead at IBC. Zach Manion, who needs no introduction. Yelena from Informal Systems. Felix from Chorus One, and the list goes on. Sunny Agrawal, Adrian Brink, and so on. So if you want to attend that, there are still tickets remaining, and it's free. And there will also be a shuttle from the Cosmoverse venue. And so you can get your tickets for that over at interchaintravel.xyz. I'm putting that right here, interchaintravel.xyz, and we'll also leave a link for that in the show notes. So do attend if you're in Medellin. It'd be great to see you. With that, yeah, Sergey, how you doing? You're in New York for mainnet right now.
That's right. Yeah, we have quite a few folks from the team here. Have a booth. We're doing a side event a couple days ago, so it's pretty fun location.
Yeah, I was talking to someone earlier about, like, I remember being a moderator on a mainnet panel, when it was still the first one, when it was an online event, like during COVID, and they were just kind of putting this conference together, and now it's like this massive thing. And I've actually never been to a physical one, but I'd love to at some point.
So you were on the testnet before it became mainnet.
Yeah, I was on the testnet. Yeah, I'm pretty sure. Yeah, I remember, like, I was talking to the team, and I'm pretty sure I did do the panel there. But yeah, and like it was right when like Hopin was taking off, and like all these conferencing platforms, and it's just like this. I just get these memories of like entering the new world, right? And like,
yeah.
But enough about that though. But so yeah, tell me a bit about your background and why you chose to work on this problem of cross-chain communication.
Yeah, I mean, my background is kind of a mix of distributed systems and cryptography. I worked on things like software-defined networking. I studied formal cryptography at MIT in grad school, doing a lot of protocol design, system design work. And then, afterwards, I helped to design and take Algorand project to the market with my co-founder Yorgos, Sylvia, a few other folks from MIT. So that was pretty fun. But then after launching Algorand, we just saw like an array of other, beautiful ecosystems being developed, and we kind of realized that kind of connected them together and providing a unified, seamless experience for the users to interact with all of these applications being built in different blockchains. It's going to be a must to continue increasing the adoption and simplifying the user experiences. So looked at the kind of solution space, understand there are a lot of problems, a lot of gaps that will still need to be filled in, and decided to focus on this problem kind of full time. So, and it's been a pretty fun journey over the last few years.
And when did AXLR launch, actually?
So yeah, the network went live kind of early this year, around February timeframe. So the network has been live since then. We connected like 24 different chains. Everything from Ethereum, Osmosis, kind of Cosmos, Polygon, Avalanche, and the list goes on. We did like over, I think, 1.2 billion in cross-chain volume to date. Over 200 and over 200,000 transactions. I think 180,000 like wallets have been connected through this ecosystem. So it's pretty exciting.
Yeah, I mean, I use it like several times a week, and yeah, the experience is like, yeah, it's pretty seamless. It feels it feels very seamless to just connect your destination wallet and the wallet where you're connecting from, and it just works. And now, I mean, I primarily use it with Osmosis, and now the integration is just so much better now that there's this Osmosis integration built in right into Osmosis, so you don't even have to go to the satellite UI. You just in Osmosis, you hit the withdrawal, the AXLR window pops up, you connect your MetaMask wallet or whatever wallet you want to send those tokens to, and it's like really fantastic. I think this is really the direction in which the UX needs to go.
And I think even one point on that, right? Like for things like USDC assets, like you actually don't have to send them from like a MetaMask wallet, right? So I think the kind of the beauty of what we have built is that you get this sort of deposit address at Osmosis, and then you can send a deposit there from like Coinbase, right? From Binance or anywhere you have those tokens, and then even though they will go through Ethereum, they will go through Axelar, they will go through IBC and like arrive at Osmosis, like you're never going to be exposed to like a single step. You never even have to pay gas like on Ethereum for it.
Yeah. I mean, I think the user experience question around bridges is really a crucial one, and it's a topic that has been coming up. All the conversations I've had with people building kind of multi-chain composability and communication protocols. But yeah, before we talk about that, I want to ask my burning question, which is why is AXLR secure? And what's your pitch here for like why people should use this bridge and not another bridge, and why it's not going to fail like so many others?
Yeah, I mean, at the very core of it, the security comes down through achieving it through strong decentralization properties, right? We have seen it over and over in the space that the solutions that remain kind of robust are the ones that are decentralized. So, and the very core of it, Axel Network is a decentralized network powered by Tendermint, and the kind of Cosmos SDK. So it has an open validator set. Anybody can join, anybody can participate, anybody can send transactions, right? Anybody can use it. And a lot of other kind of Gen 0 bridging protocols, they're all centralized, right? They have kind of 2 out of 3 multisigs, or they have like some federated oracles, guardians, whatever they call them, and you kind of relying then on those individual deployments for trust. And like in Axelar, you rely on the protocol security, right, and the decentralization through the validator set. So that's one thing. That's the very core start, right? You have to have decentralization, you have to have security. That's how you get robustness. And from there, security really is a combination of kind of good engineering practices, rigorous audits, security and safety features. And I think if you look at it, we have an array of all of those mechanisms we've been working through, kind of investing heavily in it, and we'll continue doing so. You're on mute.
What are the trust assumptions that one needs to make when using AXLR? And so maybe like to put this in context, there's obviously like different types of bridging technologies. I think like on one side, on one extreme, you have maybe like the super high trust bridge, and you gave an example, right? Like a multi-sig would be a super high trust bridge, where the assumption is that you trust these participants. And then on the other extreme, you maybe have something like IBC, where you don't trust there is no bridge. Effectively, you trust the security of the other chain, because it is a chain that is verifying another chain's consensus. Axelar sits somewhere in the middle. What trust assumptions does one have to make? And at like different layers of the stack, let's say, of the consensus stack.
Yeah, no, makes sense. Yeah, I mean, I think okay, let's first of all, I think like separate, right, like trust assumptions of the like the underlying security model, right? And trust assumptions that come with implementation. Because I think, like, for instance, if you talk about IBC, right, while kind of in a pairwise world, right, you have the ideal security, right, where everything is verified through the light clients. If you were to implement some of this logic, like, let's say, like in smart contracts, then your sort of trusted computing base and the trust assumption is going to be that this logic that validates consensus implemented in a smart contract is actually correct, right? Which is actually a pretty big, like, code base that you're going to have to trust, right? So AXLR, kind of like you said, I think it sits kind of closer to the IBC model, where from AXLR to other chains that we connect, it's actually similar type of like client verification, right, where Axelar assigns messages and they're posted on the interconnected chains, and then those interconnected chains kind of know of the validator set of Axelar, so they just kind of verify those messages. And then on the other end, when the messages are outgoing from some of the chains we connect, Axelar validators run a consensus mechanism, right, that validates the messages, and the majority of the validators have to co-sign and authorize every request, and then those messages can be forwarded to the destination chain, right? So the difference between, let's say, like an IBC connection and an Axelar connection is that one-way connections are about the same. You have about the same trust guarantees, but the reverse connections is because we don't want to have to parse this kind of complicated light client logic. Then we run a consensus, right, at Axelar, and then you rely on the security of the Axelar validator set, right, to authorize the messages and finalize them. And I guess, like, the other point to mention, though, even though with things like IBC, you actually get strong security in a pairwise world, but most of the time, when you look at networks that will have kind of a millions of connections down the line, you are probably going to be trusting some intermediate network to process your messages anyways, right? And you're going to be relying on some intermediate message because we can't have kind of quadratic number of connections across a million chains, right? So you're always going to have hubs.
Can you expand on that a little bit?
Yeah, so let's kind of
that's something I'm not actually, I wasn't actually aware of, or I hadn't considered.
Yeah, so if you take a step back, right, I am a strong believer in a multi-chain world where we'll have, thousands or, millions of chains down the line, right? And then you have to understand what are the possible topologies in this multi-chain world, right? And consider two extremes. Extreme number one, everybody connects to each other directly, okay?
Yeah.
In that extreme, you're going to end up with, kind of a quadratic number of connections across everybody, divide by two. Which is completely impractical to scale, right? Like, that's a astronomically high number. Everybody's going to have to manage their own IBC channels, relayers, and so on and so forth, right? So the internet is not connected that way. No large network can be connected in direct connections. Okay, so then you have the other extreme where everything is connected through like one hub, right? That's another extreme. Again, like you have strong properties that every connection made to the hub is automatically connected with everything else, but you can't have a million chains connected to one chain, right? Like, this is it's still going to be hard to manage. So the reality is that probably we're going to end up with a hybrid model, right, with a mesh where you have some direct connections, some hubs of transportation, so-called, right? And whenever you then communicate in that model, your traffic will probably go through some type of a hub or network that you're going to have to trust anyways. Right. And so that's, in that model, then, you probably will be taking assumptions that these transportation hubs are sort of secure in the middle that process your messages. You're going to be trusting its validator set. And in that case, the security that you get will be pretty similar to what you get with Axelar today anyways.
Okay, interesting. Yeah, I hadn't considered that as the scales, like that. Yeah, the sort of, as we have more sovereign independent chains that want to connect to other chains via protocols like IBC, you just end up with this massive number of connections where every chain is wanting to connect to every other chain, and you have like this kind of quadratic expansion of the number of connections. And I mean, I guess in the real world, that's also not how, if you look at something like networking, like the backbone of the internet. We don't have every computer connecting to every other computer. We do use this kind of hub and spoke model where your computer connects to the ISP connects to some sort of what do you call it, like a level 3 kind of traffic routing center, and then those connect to each other. And so we do have multiple hops until you get somewhere else. And I think it makes sense to look at blockchain transactions also as evolving in this direction.
And that's why, I mean, the way that I think about it is that we're sort of building these kind of, airports and air traffic control system, right? Where kind of it's the network that's been designed to deal with, security compromises, to deal with, interchain communication. And so all the protocol features of this hub are then kind of optimized to deal with cross-chain messaging, right? To guarantee strong liveness, robustness, and, UX properties. And underlying connections, we actually support, IBC, right? Because Axelar is based on kind of Tendermint chain, so you can connect IBC. If more chains, support IBC, great, we'll connect it. But there's a lot more than the security of cross-chain communication comes down to a lot more than what does my connection between A and B look like, right? Like underlying protocol can continue improving, and it should continue improving, and the verification should continue improving. But when it comes to really global cross-chain communication, it's really about thinking about like, what are the network properties we need to provide to deliver those better guarantees at the end of the day? And it's way beyond like what is an individual like pairwise connection needs to look like.
Okay. So what chains does AXLR currently support natively?
Yeah, I mean, I think over 23 chains have been live, right? Ethereum, Avalanche, Polygon, Moonbeam, and sort of Polkadot ecosystem, Osmosis, Cosmos Hub, Secret Network, Stargaze went live recently as well. Kujira is live, Juno is live. So yeah, you can go to kind of axelarscan.io and you get a pretty good look of what's been activated.
Okay. Yeah, there's like I feel like the number of chains is growing all the time. And yeah, I want to talk about the network architecture. And so looking at it from maybe the lower layers of the stack, right, and the network itself. So the validators. Can you talk a little bit about what their role is, what they're actually doing? So I understand there's like some multi-party computations that's going on when they're where they're signing transactions, but then individual chains are also verifying transactions, in their own individual chains, and then relaying those to Axelar. Can you kind of describe all of these interactions from the bottom up?
Yeah, for sure. I mean, I think we actually have a pretty nice tech diagram. Let me see if I can quickly pull it out and walk through it. I think it'll be easier. Let me see. Yeah, can I share my screen quickly?
I think you should be able to.
Okay, let's try that.
There
All
we
right,
go.
can you see this?
Yes.
Yeah, awesome. So yeah, if you go to our blog, Axel Network blog, and there's a kind of an article on the introduction to the Axel Network. So high level, this is how things work, right? We allow developers to build anywhere they want, right? Meaning that you can deploy your application, let's say on Ethereum, and you want to go cross-chain. So how could you go cross-chain? We'll expose an API, essentially, and an SDK that allows you to talk to what we call as a gateway. Okay, a gateway, you can think of it as a local kind of a router that allows you to send messages to other chains. Okay, so same as like at home, you have a router, you can send messages to the router. What's going to happen with those messages? Infrastructure underneath it will take them and deliver it anywhere they need to go, right? And so in the same way, sort of these gateways are kind of objects or smart contracts that you can send the messages to. And then underneath it, there is what we call the cross-chain gateway protocol, which is the protocol that Axelar is based on. It effectively does three functions. So A, validators collectively observe these gateways and then vote on events from them. right? So they run a consensus protocol to finalize the state of those events. Subsequently, when they reach an agreement of what needs to happen with that event, they run like a multi-party protocols to collectively kind of co-sign and authorize a message that then can be relayed and posted to the destination gateway on the destination chain, right? So in a simple example, if you send in tokens from Ethereum to Avalanche, then the message to the gateway is, send some USDC, for instance, right? That message is then finalized by the protocol. Validators collectively sign it, produce a message that anybody can take from the Axelar network and relay to the destination chain on Avalanche, post on the gateway, and from there, kind of the application logic kicks in to transfer that token to the user wallet or invoke an application call or perform a cross-chain call, and things like that. So that's a very high level.
Okay, that's really clear, and I'd like to maybe stop on each of these layers and dive into each aspect. So at the application layer, I think we could think about the basic level will be something like Axelar satellite, right? It's like some system, some kind of token transfer mechanism. But at the more complex layer, it could be an integration in Osmosis, for example, where directly in the application you have the ability to send tokens or make contract calls to another chain. So think of it as like you're in Osmosis, you want to withdraw tokens to Ethereum. That application is what you interact with, and it is where you choose to say, I want to send these tokens over here. But it could also be something more complex, like, hey, I want to interact with this contract, or I want to interact with some application on another chain by perhaps voting with my tokens, or doing some other sort of more like messaging style transaction rather than a token transfer style transaction. The gateway, these are contracts that are deployed on each individual chain. Is that correct?
Yeah. So for chains that have smart contracts, there are smart contracts. For chains that don't have contracts directly, let's say some Cosmos chains, right? Then it kind of goes through an IBC channel. So it's not quite a gateway, but even IBC channels, they serve an account, right, on chain that's created.
Yeah. Okay, interesting. And so let's just look at kind of EVM or smart contract chains for a moment. I'd like to talk about the IBC stuff first. So you have a contract over on, say, on Ethereum or on Avalanche or on Solana, I suppose. And that contract, is it right that the validators in the Axelar network are hold as a multi-sig key, as a multi-party computation threshold key, the signing key for that contract, or some sort of admin key to interact with that contract? Is that correct?
That's correct, right? Like, so the validators effectively have a key that's shared across them, right? That key, cannot be authorized by any single validator, but a majority of the validators, when they sign a message, that message can be posted to the gateway and executed, right, or validated in some sense. So the network validates messages, right, and then you have application logic that says, if the message is validated by Axelar, do X, right, and so that is sort of application layer logic that then do X can be anything from minting and a contract call and so on and so forth.
So the validators effectively are engaging in a big multi-party computation game at all times, where they're receiving messages from each of the chains. I guess when a validator on the Axelar network is including transactions in blocks, what he's actually doing is saying, these are transactions that I've read sort of in my kind of mempool. I've ordered those transactions and put them in this block. And then as a validator, I propose all of these transactions for all of the validators together to sign a multi-party computation effectively that is executing the transaction on the gateway chain.
Yep, that's correct, right? And I think for those of you, for instance, that are familiar, with kind of an IBC model, is actually pretty similar, right? In IBC model, you still have kind of consensus. A consensus is nothing more than a collection of validators that kind of collectively co-sign a block, right? And then you have IBC connections that verify those blocks. So it's pretty similar in this case, that Axelar validators produce a block, right, or a batch of messages, and you can relay that block to the destination gateway and it would verify that the correct validators have signed it, like it passes a certain threshold, and then you can execute it.
Okay, and what's the threshold for this multi-party computation?
Yeah, so great question. So we actually implemented recently a mechanism called like quadratic voting, right? That allows us to keep on increasing the decentralization of the network and keep on increasing the threshold. Right now, the threshold is like 60% of the quadratic votes of the validators. So practically, that means that over 24 validators at least have to co-sign every message.
Okay, interesting. And so I think from the point of view of like a smart contract chain to a smart contract chain, we've covered that. What happens when dealing with an IBC chain? Is it just that AXLR is connected to IBC routes for all of these chains and is effectively minting? So let's say we want to send USDC from Ethereum to Osmosis. Osmosis is a IBC chain, and so therefore you're kind of minting a representation of that token on the AXLR network, and then sending that token via IBC to Osmosis, right?
Correct, right? So this is back to my point where kind of interoperability is really more than what a pairwise connection looks like. And so one of the core functions that Axelar network does is what we call as a translation layer, right? Meaning that you have messages that are arriving in a certain format. You want to send those messages to other chains that have a very different message format, whether or not it's IBC or something else, right? So how do you do that? And that's where kind of the Axelar network takes this functionality and says, well, okay, I can actually translate a message from Ethereum to a message to IBC. The way that I do it is I simulate that message on Axelar, right? So if it's a token mint, then we'll mint it like on Axelar, and then you can route it through the kind of native protocol within those ecosystems, from there. So in that case, yes, there's a translation layer that happens effectively between those IBC messages, right, and EVM messages, and Axelar acts as a sort of simulator that allows you to do the translation in the middle.
Yeah, so this works for things that are fairly standard for, like, for instance, sending tokens, right? So you're gonna create some representation of that token on AXLR and then send it either way. But for things that are, I guess, more generic, where I guess maybe in the future when Cosmos chains have this interchain accounts model, chains might have very unique messages, and like some Ethereum dApp could want to interact with the Cosmos chain, but it's like a very specific sort of message. From that point on, then there's just like a direct passing of that message, and because otherwise it just feels like Axelar would have to integrate like so many different message types when a lot of messages might be non-standard. Does that make sense?
Yeah, no, it makes a lot of sense, right? Like, yeah, so on our gateways, we effectively expose 3 functions right now, right? You can send a token, you can send a message, or you can send, a message with a token, right? And I think those are actually like really powerful combination of those 3 messages. So same thing in Cosmos. For now, within Cosmos, we extend the function to send, a token. But as you pointed out, through interchain accounts, one of the next network upgrades that we'll be doing over the coming months is to extend this send message and then send message with the token function to be able to translate between IBC messages and interchain accounts to EVM messages. And yeah, in that case, Axelar will relay a generic message, right, and it will be executed at the destination Cosmos chain. There are certain functions that people have asked us actually is like, oh, could you actually put this, message type or like this logic on Axelar to make those things easier, so we don't have to like deal with on our destination chains?
Yeah.
So I think that would be actually super powerful, where effectively you can have like a combination of some logic executing like on Axelar to parse some message, and then some logic executing at the destination chain to streamline the communication.
How does Axelar deal with different finality assumptions? And we've talked about this also on other episodes. I guess now, like with Ethereum being proof of stake, some of the more complex finality assumptions maybe are around more probabilistic finality or are being phased out. But I think different chains still now have different finality assumptions. How does it deal with that?
Yeah, I mean, on a high level, Axelar implements what we call as like a finality gadget that can be tuned in depending on the parameter of the network to finalize transactions. So the validators for every chain decide what the finality rule looks like. For EVM chains, you have to wait for a certain number of blocks, for instance, right, of a message.
Yeah.
So for Ethereum, there's like a finalization tag you can call. For Avalanche, you can wait for like one block and then you can consider your transaction as finalized. And so, yeah, depending on EVM chain, it's sort of a configuration parameter that gets deployed with the finality rule, and then your latency and everything else is then sort of a function of that finality. Let me actually share this very quickly because I think this is pretty powerful as well. So if you go to Axelar scan, which is our Explorer, right? You can actually see how different finalities of different chains affect latency of the cross-chain messages. So it's like Axelar scan, like general message passing. And so you can see like from Avalanche, to Moonbeam, transactions take, on average, like a little bit over a minute and a half. So from Binance Smart Chain, it's like 2 minutes, right? And, kind of
interesting.
A difference from there. We actually expose like very rigorous statistics around it. You can see kind of average time execution from every different chain. So Ethereum is the slowest, and the transition to proof of stake did not help that. I think it actually
really
it's even slower now, right? On average, because you're waiting for like 64 to 96 blocks until kind of 2 epochs have passed, and so in reality,
right.
the latency from Ethereum has actually increased.
Okay, interesting. I hadn't considered that. So. Does AXLR also, or will it also provide a callback? So if you have a application calling a message and that application wants a response, so in a sort of interchain queries, interchain accounts fashion, as it's been proposed, would you be able to have a return back from the application?
Yeah, great. We already have return of the application. We actually have applications that are built in with it. So let me take a step back. So I think what we're building, right, like is really kind of you can think of it as sort of the, UDP or TCP/IP sort of layer, right? And then from there, you can build all kinds of sort of applications on top of it, right? And I think like callbacks is a type of an application layer protocol that can be built on top of Axelar, right? So it's not even that we have to provide anything for that. Any application can instantiate it. We have examples for how to do callbacks, and you can have nonce execution, you can have sequence execution. So Axelar network by itself guarantees kind of unordered delivery of messages, right? And you can, on top of that, build various application layer properties to get ordering of messages, to get like callbacks, to get encrypted messages, and so on and so forth. And so those are all like application layer protocols, and like we gave a bunch of examples how to instantiate those.
Okay, interesting. Yeah, so I want to come back a little bit to the security aspect. And so where are the security risks? I guess like there's liquidity being held in Axelar, and if you go to Axelar scan, like you've got all the liquidity pools there. Is that liquidity on the Axelar chain, or is it being held? I guess it's being held in the individual contracts on each chain, right?
That's right. Yeah.
Yeah, and so I guess looking at something like the Nomad hack recently, which was like a smart contract bug, and there's been like tons of smart contract bugs. I think one of the security risks there that people should consider is that like their asset, the liquidity of the pools on each individual chains like are at risk of being, say, hacked or something like that. I'm sure you guys are doing like tons and tons and tons of auditing to make sure this doesn't happen, but it is a risk. What are some of the steps you're taking to mitigate potentially worst case scenario style effects?
Yeah, great question. So I think security, right, like is really a function of kind of 3 different things. I think you have to start with the core design that's secure, right? So kind of decentralization is like the best primitive we have to guarantee security, and diversification of the validators. From there, you have to have kind of robust, engineering practices, and it follows by kind of operations, audits, bug bounties, and like safety mechanisms, like you said, to deal with worst case scenarios, right? So recently, actually, wrote a blog on security as well. You can check out on our website. And when it comes to the latter, I think we're doing like rigorous audits, right? So if you look at it, like we've done like over 27 audits of our network, everything from the contracts to the back end. B, we are have functionalities that allow us, for instance, to kind of suspend a traffic from a malicious chain, right? So as an example, when Terra was going down, we suspended traffic from Terra, and that prevented any kind of arbitrary mint of those functionalities of those tokens, like on other chains. And then finally, on our gateways, they have things like rate limits, right? So our gateway actually processes up to a certain bound of messages that are token related per given interval. And then when that limit is reached, you have to wait until a reset of that limit, and it kind of depends on the asset and the volume and things like that. So in the worst case, if there is like a bug on the AXLR network, then what can be drained from the gateway is capped. And we also have bug bounty program for over 2 million that's running, right? And through Immunify, and you can kind of take a look at that, and that's another kind of a piece of process that we're putting in place.
And have you guys, like, as part of like the security, so your security practices, do you have like internally, do you have like a process, or do you have, I guess, like, I don't know, some sort of a war plan for like if a hack does occur, we've done all these audits, we have these rent limits, we have this, we have like, have you done like dry runs for like how to mobilize the team, how to contact, like, so that you're ready if this does happen at some point?
Yeah, I mean, lots of work, right? Like been put around those things. I don't think I want to, talk about like specifics of it, but
Sure.
absolutely right. Like I think, if you look at our team and like background, I think building secure systems is what we've been doing for the last, kind of 10 years, right? It's not an easy thing, and I think this is a kind of one of the hardest problems to build securely in the space right now. But and I think we take it like seriously throughout the whole stack, and like you said, like operations and is a part of it, and like we even coach our validators. Even validators have things like key rotations that they have to do on the network, right? So I think this is what people don't realize, but like you want to make sure that the keys are actually refreshed and updated, that protect the networks, and so validators are required to do that as well.
Yeah, I mean, another aspect I want to talk about here about security is the validator network itself. Currently, I wasn't able to get an idea of this, but like the AXLR token isn't on public markets yet. But does it have a price already? Like, do you have an idea for like how much money is backing the validator network?
I don't have idea, yeah, because the token is not rolled out,
Yeah.
so it's been sort of delegated to some validators, but it's going live kind of next week, and I think from there, kind of the market will dictate it. But I think one thing to note on that, I think while everybody sort of talks about like the price of Axelar and things like that, I think with things like interchain security, right? The security across different networks can actually be shared, right? Where like Axelar network can borrow security from other networks that it connects. It can lend security to other networks that may be smaller and things like that. And so I think we're going to start seeing more and more of that, where like the value that we transfer kind of actually is directly related to the security of some of the networks that we transfer it from, and we can borrow the security from them through this interchain security properties.
So yeah, so like if the Cosmos hub, after it enables interchain security, say has like 200 or 300% the security of the average Cosmos chain, or I don't know, like let's say Osmosis starts doing shared security, you would you would consider doing shared security in order to increase the security of Axelar and sort of boost its security profile relative to those other chains?
Yeah, oh, for sure, right? Like I think for chains that have a lot of traffic, right, or have a lot of benefit from Axelar, they're all going to be interconnected. One will borrow
Yeah.
security, one will lend security in like different combinations. So like Osmosis, for instance, as well. Like I think there's going to have to be some type of a shared security across Axelar and Osmosis, given how much traffic will get there. So I think like the whole ecosystem is going to be more working as one when it comes to economic security, as opposed to these diverse individual security based on like one token or one asset.
Yeah, I think that's one of the most interesting things that I'm anxious to see play out over the next couple of years is this idea of like meshed security across different ecosystems and different networks. And certainly interchain security is like one step in that direction, but as other chains also enable shared security, yeah, it's going to be interesting to see how like those network dynamics play out, and also sort of in that cross chain world, right? um, yeah, I want to talk about user experience a little bit, because I know that's something you're also kind of interested in and passionate about. But what's the opportunity here for MEV? Because the validators are in effect ordering transactions as they see them come in their mempool. Are there MEV opportunities on Axelar, and have you seen any of that activity already?
Yeah, I mean, I think when it comes to cross-chain, MEV kind of gets to the next level in some sense, right? You can have MEV, sort of on Axelar, right, and like relay mechanisms and things like that. I think inevitably MEV needs to be solved like at the application layer, right, through things like commit and reveal protocols, and we actually working and kind of have worked on some designs there. We haven't seen it yet, or at least not that I know. But yeah, probably start seeing it at some point, and we'll have to solve it, but not at the network layer. I think this thing will have to be solved at the edges.
So you are you of the opinion that like XLR shouldn't should let MEV, like the market, sort of play out, or should XLR take a role in preventing MEV from happening? Are you pro MEV or against MEV?
I think it needs to be at the application decision, right? I think so at Axel Network, we can solve it if we need to, and we actually can solve it very efficiently because we have this, kind of multi-party computation, so you can actually efficiently deploy like a multi-party kind of encrypt and decrypt protocols in Axel Network.
Yeah.
But I don't think that will, I guess, even if we solve it in Axelar, I don't think that's enough to solve MEV for applications, because you're still going to have MEV, and relays. You're still going to have MEV at the destination chain and things like that, right? So it's just like we can solve it, but it's not enough. That's why I think in a world with multiple chains, with potentially multiple hubs, you have to solve it at the edges.
Mm.
So solving it in Axelar is just not going to solve the problem at the core.
Okay. Yeah, so let's talk about a little bit of the application stuff. So what are people building on Axel? Like we've seen, we've talked about Osmosis already, and obviously Satellite has been kind of the flagship application. What other cool things are people building with XLR?
Yeah, I mean, I would say like all the applications that you have seen in this space that have any type of a product market fit are now being redesigned in a cross-chain native way, right? So things like cross-chain swaps, cross-chain borrow and lending protocols, NFT, cross-chain NFT. So like MintDAO launching a cross-chain NFT collection, with Axelar. You have gaming applications and things like that. So all of them are starting to think about, what does my cross-chain native experience look like, right? How do I redesign my application? We have like over 100 projects like across pretty much all of the categories that are building.
Like I guess as bridges start to come in place, what does the ideal future look like? So like right now, if you want to move tokens from osmosis to another chain, like you're still interacting with this kind of interface where you have to specify where you want to send it and stuff. Like, do you think that there's a future where you just go on an application like OpenSea, you've got a wallet with tokens. It may be an Ethereum, it may be like an Ethereum wallet or something that's compatible with OpenSea. It may not be. And you just get to pay with whatever tokens, but in the background, those protocols that are executing transactions cross-chain, making swap, etc., and moving those tokens to the wallet of to the destination address, and then like providing you with your NFT, for instance. Like, is this the holy grail, or like how do you think we'll get there? And
yeah, I mean, I think the holy grail is that as a user, having some asset, you get to interact with any application, any chain with one click from your wallet, right? Like that's really the holy grail, without having to think about how do I bridge, how do I move my tokens, like how do I go from one network to another, how do I pay multiple gas fees, and so on and so forth. And I think with Osmosis, we're starting to get into that experience, right? That I mentioned, that kind of you go to Osmosis, it will give you like a deposit address, right, for asset that you want to transfer, like USDC. You can go to Coinbase or Binance. You can withdraw directly to this address. Never have to touch Ethereum. Never have to pay gas on Ethereum. Never have to pay gas on Axelar. Never have to bridge anything, and like your asset will just arrive in this application. So we're really kind of connecting application to application directly through all the infrastructure underneath it, and users can kind of go between them. So that's what I think is going to happen more and more, and that's certainly the world that I want to see, right, where people can interact with an application from multiple networks, from multiple wallets, without having to think about how to do it. Really one-click experience, what we're after.
But the competition is fierce, right? Like, you guys are one of many protocols that are building interoperability solutions.
We are one of many, but we're the only ones that sort of decentralized and secure and can scale to many-to-many connectivity, right? So yeah.
Well, I think some people would I hear you. I think some people would also say that they are decentralized and can offer like many. I mean, I certainly think you guys are like in the top contenders to be successful.
I actually encourage people to look at the report. Like Li-Fi put a report, right, comparing security and other properties of different solutions in the market. It's pretty clear there, I think, who is actually decentralized.
Who put out this report?
Li-Fi.
Li-Fi. Okay, I'll have to put that in the show notes. Okay, cool. I haven't seen that thing. Yeah, cool. And one other question I had around like user experience. How do you think we solve the fungibility problem of bridge tokens?
Yeah, I think the users don't have to think about bridging tokens, right? I think the next generation of applications will what I call be cross-chain native, where maybe the tokens are bridged on the back end, but they can be, kind of a swapped, right, for the right representation, or maybe the tokens are not even bridged on the back end, and you just kind of send in messages to compose your applications, right? So as an example, if you take in a cross-chain loan, you can do it by sending tokens to a destination chain and take in a loan against this asset, or you can send, you can lock your token on the source chain and just send a message to the destination chain that says, I locked my tokens in a contract on a source chain. Could you please authorize a loan to me on this destination chain, right? In that case, you actually don't move the tokens. You're simply moving a message that allows to execute a particular sort of user action, right, on the destination chain. And so I think we're going to live more and more in that world where for some applications, it makes sense to move tokens, but for a lot of applications, it makes sense only to send a message to execute a user cross-chain activity.
Okay, so I guess in this loan example, let's maybe try to construct an example here. So let's say we had a lending protocol on chain B. You have some native asset on chain A, let's say USDC. You want to borrow some tokens over on chain B, but that chain B pool doesn't support USDC directly or natively. On chain A, you would lock your tokens, send a message to chain B, say, hey, I've locked these tokens. There's my collateral. I can borrow against it, but you're never actually moving the tokens over to chain B. You're just kind of locking them as collateral somewhere else. Is that kind of
That's
what it
right.
looks like?
Yeah.
Okay, interesting. Yeah, it's an interesting model. Yeah, and so then
So
therefore, you don't need
kind
a
of
bridged asset.
you don't need to bridge assets, right? Like I think the way that I like to think about it, you can move assets to the program, or you can move program to the assets, right? And like the model of sending messages is really a model of where you can write your program as a message, right? You can move it to the asset, execute an action, and then return the result back to another application, as a sequence of contract calls or user activities. And so kind of traditionally, by making users move their tokens, we kind of turned users into sort of human routers, what I call, right? But with general message passing, we can automate all of those like user activities and write them down and like abstract them and send programs to be executed across chains.
So then effectively you have, okay, this is cool. So you could effectively have some sort of a lending pool that has collateral that is represented as claims to lock tokens on like tons of different chains. Wow. Okay. I had never thought of that. That's okay. That's really interesting.
So I think that's why I said, right, like there's going to be a paradigm shift of like what it means to build a cross-chain native application, right? Where it's not about like which wrapped assets you're going to list. That's not what it's about. It's about architecting your application in a way that can talk to other applications, other chains, and send messages and kind of benefit from all of the liquidity of the whole ecosystem without having to fragment it and like have users move the tokens back and forth. So this is what I call is like cross-chain native deployments, which is what we're working on with a lot of the builders on top of Axelar.
Super cool. Yeah, one like kind of side question here. When you move, let's say you move USDC, like native USDC from Ethereum to Osmosis. Right now you're getting a wrap token. But Osmosis will support USDC at some point. At least that's what Sunny has claimed. Well, in the future, then will you just get native USDC over there? Like, will AXLR be making that conversion, or like kind of having a liquidity pool there that just gives you the native one, or will you still get this kind of wrap thing?
Yeah, you could definitely just do like a swap and get the native. We actually have a project, kind of Squid, building on top of Axelar network that does that, right? So it uses Axelar USDC as a routing asset to send messages across different chains with that Axelar wrapped USDC. But then on destination chains, it gets like swapped for the native USDC and like the message is executed. But the user never have to take those actions, right? Because they can again like code it as a message, and you just get like the USDC of the deepest liquidity.
Interesting. And I guess so. Right now, like USDC is probably like the asset that gets circulated the most. I'm just looking at the total locked value, and it's something like 60 million USDC. Or 68 million, and then the next asset after is like $8 million worth of wrapped ETH. So USDC does serve as sort of a routing asset in many ways, right? Yeah,
that's right. Yeah.
Okay, interesting. And do you think that will continue to be the case? And if that's the case, like what kind of maybe regulatory liabilities do you fall under, especially now with this all this talk about regulatory stablecoin regulatory action?
Well, I mean, Axelar network itself is sort of decentralized network, right? So in the same way as you have kind of Ethereum that produces blocks to transfer messages, so in the same way Axelar produces blocks that transfer messages across chains, right? And then the network itself and kind of the properties of it, kind of preserve the decentralization and security aspect of the underlying consensus.
I just noticed something here. So it's I'm discovering this total value locked page on Axelar Scan. It's quite interesting. So you've got this slide over here. So it says 8 million to EVM, 82 million to Cosmos. Is that total value logged, or is this transfers?
So so my guess, I don't actually know. I would have to double check with the team, but my guess is that to EVM, meaning that it has been minted on those, EVM chains from other ecosystems, right? And then to Cosmos is probably from EVM, from all of the EVM to Cosmos, what has been moved.
Okay.
So a lot of the traffic from EVM to Cosmos is that what we're seeing, I think.
Okay. This is an interesting indicator. This is interesting to see that, we actually have like quite a bit of liquidity, quite a bit more, like 10 times more liquidity going, or volume going from other ecosystems to the Cosmos ecosystem, and rather than the other way around. Yeah. An interesting metric.
I mean, it makes sense, right? Like, because I think in Cosmos, like every time a new chain is added, like it needs to bootstrap itself, right? And it needs to have liquidity. And so, I think once we make a connection, like that liquidity kind of flows in. Like you have to, like it is a bootstrapping effectively tool for a lot of the chains that are launching within Cosmos.
Yeah. All right. Well, let's last topic here. Yeah, the token is going live, I believe, on the 27th.
That's right.
We have people asking questions here in the chat, like, on which exchange will it be launched on? I don't know if you have answers to that yet, but yeah, talk about sort of the roadmap going forward as the token launches and how that's going to affect the validator set and all these things.
Yeah, I mean, as the token goes live, right, like the token on the network is a sort of a utility token, right, that you can use to stake with validators that provide security and pay kind of gas for processing cross-chain transactions. So I think one interesting property actually of Axelar token is that the token is used every time you go in cross-chain without you even realizing it, right? So every time you send in like a cross-chain call from like Ethereum to Osmosis, user pays gas like in the token that they transfer, let's say USDC, but that fee then is taken to be paid gas fee, like on Axelar, on relayers, right, on Osmosis kind of destination, and same thing for the EVM chain. So yeah, kind of in the token used like as a primary mechanism to to secure the network and protect it against kind of DDoS, Sybil attacks and things like that.
And yeah, like in real terms, what's happening on the 27th in terms of because currently the validator set is, I guess, all the investors in AXLR, right? Or mostly
not really.
No,
I actually most of it is community. So we ran like a test net, for the last year. A lot of like community validators, everybody from like Cosmos Station, right, to Chain Node, Figment, Chorus. They've been running nodes, participating in test network, and when they felt comfortable enough, they upgraded to the main network, and then some tokens were delegated to them to run validators on the mainnet. And so, yeah, as of 27, because the token is just going to be widely circulated, then anybody can delegate to any validator that they choose, and kind of the network will adjust its sort of top performing validators based on this permissionless set from there.
Okay. And then at that point, also the validator set will expand, because currently I think it's limited to 50, and you have plans to expand the validator set probably through governance or something like that.
Yeah, it's a parameter, right, in the network. So I think we'll gradually keep on increasing it as we get more people, as we get more confidence and like stability of the network and things like that.
Okay. Well, at Interop, we're certainly interested in running a validator, and we've been looking into it, and certainly we'll launch a validator whenever it's possible. So if you're watching this and you have in the future and have XLR tokens and want to stake them with us, the link to that will be in the show notes. Thank you, future delegators. Yeah, and so the AXLR token will be minted on the main chain, and then there's this wrapped AXLR that will exist on all the different chains that you connect to as a representation. So do you plan on having these tokens also have sort of like liquidity pools on those tokens with wrapped AXLR pairs in order to facilitate the flow of those tokens in and out?
Yeah, so kind of back to your point, right? Like I think this is going to be the first project that launches with like chain agnostic token in some sense, right? So you can have its representation like on Ethereum, like on Axelar and other EVM chains, on like Cosmos chains, right? You can move back and forth across them, and it's sort of mobile, right? Yeah, when it comes to like liquidity and other things, it is going to be public and permissionless. So I'm pretty sure there's going to be like community programs that will that will continue making use of it in like various applications and dexes and things like that. But we'll have to kind of wait and see.
Yeah, for sure. Well, thanks so much, Sergey. Where can people go to learn more about AXLR? Maybe is there any information about the token launch that you've written about or posted, and where can people go to learn about building with AXLR?
I think the best place to start is just go to our website, right? Axel.network. From there, we actually link to various tutorials of how you can participate in governance, right, or stake on Axel network through the token. Kind of bridge it. So all those functions are outlined there. There's a blog post. You should subscribe to our socials, like at AXLR Core is the Twitter handle. Sign up for Discord. There's a pretty vibrant developer community there, and get engaged.
Awesome. Well, thanks for coming on, and enjoy the rest of mainnet. And we'll definitely follow up. I think we'll have to follow up in some time when
Awesome.
after the token launches.
Awesome. Well, thanks for having me. It was fun.
Thanks.